Right, students, this is the second recording I'm doing. I hope this works now, and I hope I can get this online today. Few questions about the Grasshopper slicing both ways final file here. So this works really well. I have worked quite a bit on this definition, and I briefly talk you through the individual parts. What I want you to do is not to just use it, but ideally I would like to recreate it following all those individual steps here. Yeah. So that would be great. I'm just checking something. That is just one code that doesn't work. It's annoying. Okay, right. First question: how do I get? I put this aside. How do I get a mesh onto? Let's hide the rest here. So here I've got a mesh that is in the Rhino environment, and you want to parameterize this mesh, and this goes again as you do it with all items. So you can import meshes, you can import lines, points. So this is always the same method. So you go to whatever geometry you want to bring into the Grasshopper environment, be it a curve, a circle, a plane, a box, or a mesh in this case. So I take this battery, I right click it, and then you go set one mesh, or if it's multiple meshes, you go set multiple meshes. Here I just set this one mesh, I click onto it, and if I click onto this battery, what you also notice is that the battery, if you take the battery, let's do this again, you take a mesh. So at the moment, this battery appears, if you don't click on it, is orange. There's no data in it. If there's data in it, it switches to gray, right? There's also an indicator field here. This little orange warning signal, you can always click onto it or hover over it, and it says what is wrong with this. A floating parameter mesh failed to collect data, so there's no data in it. Here there's data in it now. Okay, I'll delete this now. And obviously we have this mesh, and we plug this in to our first section, and I'm going to go through this. So I'm going to delete this now, and I hide all of this. That we are basically, what you see here is only the parameterized mesh and the outcome of it. So perhaps what we're going to do is we switch everything off, and then we can sort of follow it step by step. Okay, so we have this mesh here now, which is parameterized. This is quite a complicated one. It's a line head. What I did, I closed the mesh. So in case you make a cut, it's hollow. Try to fill it. So you duplicate the mesh edge and turn it into a surface using mesh tools. You can basically use this one, fill mesh hole. There's another patch, I think here, mesh patch. You can also, if you select the mesh edge, you can go to standard and fill it so surface from planar curves, but this surface you need to turn into a mesh, so you need to remesh it. So best thing is you go select mesh edge, duplicate mesh edge, and then fill the hole. So once you have so again, you can't click onto this. This is parameterized, so you can look at it, but that's about it. So it appears red. And if you activate it with the battery, it appears green. So what have we do? So we look first. I have two. We basically only look at this here at the moment. So this is what I'm dealing with. So we separate this two general fields. Let's make this a little bit bigger. So everything that is up here into the violet is the horizontal slicing, and this green area is the vertical slicing. But first, you want to clean up your mesh, and you can also scale it. At the moment, I'm scaling it 1:1, but if you have a slider, you can also, increase it. Try to get it to a size of about 25 by 25 by 25 centimeters. So if you have a small mesh, you can scale it with this battery. It's called Scale. You just type in, double-click Scale, and you have various ways of scaler. So this is numerical or this is fractional. So anyway, we're not going to do that. So that's this battery. Whenever you hover over a battery, it shows you what it is. Okay, and if you need to replicate it, either copy it or you just type in, double-click and you type. What I do quite a lot is this is a data dam. So if you plug in your mesh here, if I change any parameters here, let's change this to 1.2. I can double click here, 1.2. I click the green hook. And now you see we have activated this. So everything right to this data dam is not processed. It's basically a good way, because this is a lot of data that needs to be processed. If you make changes on the left, you have to wait for a long time. So this is just helping you to navigate through rather lengthy code sections that produce a lot of stresses on the CPU. Yeah. So if you double click onto this, we see the pizza coming up on this data dam, and now everything to the right of it will be processed. So it needs to slice through this mesh and so on and so forth. And perhaps we just highlight what we actually get out at the end on this section of it. I go to the, and here, this is what we see. So this is what this section of the parametric code of Grasshopper produces. So I just want to briefly go through the various. So this area here is slicing. So what we get out is slices. So this is the original mesh, but we increase the size by 1.2, and this is the slices. Yeah? I create a patch to make sure. So again, we always had problems. So this is the outer line here. Yeah. So this is this curve. Yeah. So this is the curve. When we duplicate curves inwards, we get problems with intersecting. They basically have too many points that they sort of overlap. And that's a problem. That has always been a problem, but I've found two solutions. So this is the inner curve. We use a little Python script, which I did not code, but I have just stolen it from the web. And let's activate this. So we have, this works fine. So you can see we have the inner and the outer, right? So what I do here in this next section, let's deactivate this. So we just click on the canvas. So what I want is, I want to turn this area between the inner and the outer line into a surface, because I want to extrude that surface. So I use this battery, a boundary surface that creates, so basically creates a surface from a boundary curve. How does that look like? So it's exactly, so we have a surface now starting on the outer boundary curve. And this one here creates the same, but starting from the inner boundary curve. In order, but I just want to have this rim, so I coded this, that I subtract this surface from this surface. So we use this battery. So it's a solid difference. So I subtract the inner from the outer. And now, as you can see, we get these surfaces that represent the thickness of the laser cutting parts I want. But I want it obviously now to simulate the 5mm plywood we are using. So I extrude it into the z-axis by 5mm. And then we get this. So I extrude the surface, not the curves. Really important, right? And all I need to do is, I don't want to have everything in one cluster. I just move it to the side, and I can do this here with a move battery. Move in the X direction or the Y direction. This I can delete. I use this battery. I don't know why it shows, but this just says 400. This is a panel. And I drag it here, and if I double click onto this, so this is 400. Yeah. So this panel is just a simple data structure, or a battery that just contains number data. It's very useful. And I shift this to the right, or in the X direction, and here I can choose a color to visualize it. So okay, that's this part done. And now what I do, I take, let's just hide this bit here, double click, blindfold it. Okay, let's go back. So we have our original mesh, and I scale it at 1.2. So you can see, let's quickly have a look at this. Slightly bigger. Yeah, I scaled it up by 1.2, factor 1.2. Hold on, I think I need to do this here. I just discovered a little mistake. I need to take the center point from the scaled up version, not the original mesh. Yeah, you always can make improvements. I don't think it would make. So basically, what this battery do, it's called area. It calculates the surface area, but vitally, that's very useful. Very often, you need the center point of a geometry. So if I click onto this, you should see a green point somewhere. If we hide this. You can make it visible. So here, let's just hide this. So here, this is the center point of this geometry. Yeah. So this lower part slices it horizontally. And what do we get here? A problem. This worked last time. Does it work when I plug it into the original mesh? Let's reverse it. It's because I didn't calculate the data. Because I take some of the data from this mesh rather than from that mesh, and that caused confusion. Because I need to activate the data then. you sometimes do things retrospectively, things sometimes are not liking it. Here we go. Let's save this and let's see what we get out of it. Okay, these slices. I also want to do the offset a slightly bigger. The offset on both sides. On both sides, we don't want to have both sides cancel. Oh, it halved it. No, we don't want that. The 24, if we, let's leave that for now, but we can change this. So if you right click onto it, you can set an expression. So it halved the X component. What happened if we delete this? But this might be crucial for the code to work. So let's do 48 or 50. Because if we half it, it's 24. Okay, that looks better. And we obviously have some problem with this one here in the intersection. So this is something where you basically very often need to play around with your numbers and see whether the code works. Sometimes it doesn't work, and then you have to, if we do this, let's get rid of this expression. And change this to 20. So, I mean, basically what you're witnessing is the way I work with Grasshopper. There is something down here that prevents this line from moving upwards. So this is something you probably need to hand edit in a situation like this. Is what I would do. I just hand edit it basically, because this is the only surface that doesn't quite work out. So, but the rest is pretty good. So this is an inner curve, a better solution from an inner curve. That shouldn't intersect. And I do exactly the same. So out here, this is exactly the code I copied and pasted from up here. And I get this. So let's switch this one on. And we have the lion head intersected, apart from this middle section, which we then bake onto a baking area, and then I can just hand edit this basically. I think it's just about this line down there. We might find a setting where this works better, but I leave that to you to play around with. Let's save this now, and that should all work fine now. One notice, if you have imported this Grasshopper code and you get a warning that there's a plugin missing, for example here, this here is a part of the Clipper plugin that doesn't come standard with Grasshopper, so you just download it. Usually it automatically downloads it. If you're working with Windows, sometimes you have to manually install it. Please find on the web how to install plugins on Grasshopper. There's a special folder where you can basically just drop it. It's just a simple Grasshopper bit of code. It's really tiny, 20K usually they are, and then you can add all sorts of additional plugins. You get so many up here that, you know, countless. You could fill your entire surface here. But that comes down to your preference and what you're actually working on and which fields you're working on. So I'm pretty sure there's plenty of video plugins or sound plugins. I have not downloaded them, but if you're into that, you're more than free to, and they're all free. Yeah, most of them are free because this is still sort of like an online community here. Okay, so that's pretty much it. So try to replicate this, try to rebuild exactly what I have done here in order to understand it better and where the individual batteries live. Yeah. So you will be mainly working with the parameters tab, the curve tab, vectors, and I think I will give you a little weekly task with Grasshopper in order to get into this. This is particularly for those who work in art and technology. Yeah. Okay, that's it for now.